Fine. Are you all ready to score 90 plus or even centum in the upcoming board examination? If so, let us continue our journey towards it. Today also we'll be doing some more PYQs from chapter solutions. Hi, I'm Prasanna. Welcome to my platform, Chem Smart. Let's see what are those questions which I have brought for you today. Question number 1 is a numerical, and the question is, when 19.5 gram of FCS2COOH, that is fluoroacetic acid, molar mass 78 gram per mole, is dissolved in 500 gram of water, depression in freezing point is observed to be 1 degree centigrade. And calculate the degree of dissociation of fluoroacetic acid. Kf value is given. It is a typical numerical from depression in freezing point, and it is a 3 marker. So you have to do it in detail. It is depression in freezing point. So what all are given here? 19.5 gram of the solute. So that is W2. 78, that is a molar mass of the solute, fluoroacetic acid. Then 500 gram of water, that is the mass of the solvent water. Then depression in freezing point. Depression in freezing point means it is delta TF. That is 1 degree centigrade. And it is same as 1 Kelvin. Difference remains the same in degree centigrade and Kelvin. I have told you in one of the previous sessions. And then calculate the degree of dissociation. Degree of dissociation means it is alpha. So whenever that is asked, you have to go through the Van Hoff factor. I have told you before also. Hope you remember. So delta TF is equal to I into KF into M, where that M is W2 by MM2 into 1000 by W1 in gram. So let us substitute. Delta TF is 1 Kelvin, 1 degree centigrade or 1 Kelvin is equal to I, we don't know, into KF is 1.864 water into W2 is 19.5 divided by molar mass is 78 into 1000 divided by W1. W1 is 500. So when you do this, you'll be getting I as 1.0753. This is the value of I, what you get here. But question is about alpha. Alpha is equal to, for dissociation, alpha is equal to I minus 1 by N minus 1. For which you should know what is the value of N. Let's see how you get N here. It is fluoroacetic acid, FCS2COOH. It will dissociate to form FCS2COO minus and H plus. So the number of particles after dissociation is 2. Just like in the case of acetic acid. So alpha is equal to I minus 1 by N minus 1. I, you got 1.0753 minus 1 divided by 2 minus 1. So you will be getting it as 1.0753 minus 1, so 0.0753. That will be alpha. If you want only degree of dissociation is asked, if you want percentage dissociation, multiply this by 100. So that will be 7.53. But that's not asked here. Clear? Practice. Now the next question is another numerical question. Today I have included more numericals. A 0.01 molar aqueous solution of aluminum chloride freezes at minus 0.068 degrees centigrade. Calculate the percentage dissociation and Kf value for water is given. Here also it is freezing. So you have to deal with depression in freezing point. So that will be delta TF is equal to I into Kf into M. We are not expanding M because already molality as such is given in the question. So delta TF, aluminum chloride solution is freezing at minus 0.068 degrees centigrade. So that is TF. This is TF. So what is delta TF? Delta TF is equal to T0F, that is freezing point of pure solvent, minus TF. So for aqueous solution, water is a solvent. So it's zero. It's T0F is 0 degrees centigrade minus TF. Solution's freezing point is minus 0.068 degrees centigrade. So this will be 0.068 degrees centigrade, which is same as Kelvin. Difference is same as Kelvin. Okay. So you got delta TF. Now let us substitute. Delta TF is equal to I, because percentage dissociation is asked. So you can go through I value, 1 for factor value. So delta TF is equal to I into KF into M. Delta TF is 0.068 Kelvin. Then KF is 1.86 and the molality is 0.01. So let us substitute. So delta TF is equal to I into KF into M. Delta TF is 0.068 is equal to I into 1.86 into M is 0.01. Right. So you are getting I. When you calculate, you are getting I as 3.6559. This is what you get for I. Now you have to get alpha. But here the case is aluminum chloride. So aluminum chloride will dissociate to form Al3 plus and 3 chloride ions. That means total number of particles after dissociation is 4. So let us use the formula alpha is equal to I minus 1 by N minus 1. So that is I is 3.6559 minus 1 divided by 4 minus 1. So you are getting 2.6559 by 3. 2.6559 by 3, you are getting 0.8853. This is the degree of dissociation. So what will be the percentage of dissociation? What is asked in the question? That will be this into 100. So the percentage dissociation will be 88.53%. That is the answer. Hope this is also clear. So it is just a matter of practice. Clear? Practice all these questions very well and be ready. Okay? Now we will be doing one more question from the theory area. We have discussed 2 numericals already. Now let us take a theory question. And the question is, state Raoult's law for a solution of volatile components. And what is the similarity between Raoult's law and Henry's law? You might have by-hearted Raoult's law already. What is Raoult's law? For a solution of volatile components or volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. That is, if you take a binary solution of 2 components, how will you write it mathematically? Suppose there are 2 components in the solution, component 1 and component 2. Then we can say P1 directly proportional to chi1 and P2 directly proportional to chi2. It is always better to write the mathematical form also when you state the law, if you aim perfection. Clear? So, for a solution of volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. That is Raoult's law. Now, what is the similarity between Raoult's law and Henry's law? You know, both Raoult's law and Henry's law state that the partial vapor pressure of the volatile component is directly proportional to its mole fraction in the solution. Only the thing is that for Henry's law, that volatile component is a gas, and in Raoult's law, that volatile component is a liquid. That's the only difference actually. Okay. So we can say that basically both Raoult's law and Henry's law are connected to what? Partial pressure of the volatile component and its mole fraction in the solution. Clear? So practice all these questions very well and be ready for your board examination. So wait for the next session. Keep watching. And as I always tell you, like, share, and subscribe to my channel. See you in for the next session.